All right, Dakota, JJ, and Dominic, we are on to lessons 96 and 97. Good news for you guys. Lesson 96, we're not really going to introduce the stuff on that lesson. It is something you may get into in Algebra 2, but at this point in time, I just don't feel like it's important for you guys to learn. So we're going to skip that explanation. There are some problems on lesson 96 that you won't do. So I'm going to write those over here, lesson 96. And you guys are going to like me over the next couple of days. There's quite a few of them that we're not going to do. So please pay attention. 1, and then 9 through 13. We're not going to do those. 18, 22, and 27. So for lesson 96, those are the ones that we're not going to do. So we're going to go ahead and get into lesson 97, page 647. Graphing linear equalities. Now this is not near as hard as it sounds. It's actually pretty easy. Example 1 says determine if each ordered pair is a solution of the given inequality. And these are real simple. We've got 0.04 on our graph, and we have y is greater than 5x minus 1. And all you're going to do is you are plugging these points into this graph and seeing if it works. So y is 4 greater than, and we have 5 times x, which is 0, and then we have minus 1. And now you just solve. So we have 4 is greater than, 5 times 0 is 0, minus 1. 4 is greater than -1. And if that's true, then that works. So your answer on 1A, technically, would be yes. So 1B, we have a point of 3, -3. And our equation, y is less than -3x plus 6. It's going to be the same concept. We're going to substitute those in. So y is going to be our -3. X is 3. And then plus 6. So we have -3 less than, -3 times 3 gives us a -9 plus 6. -9 plus 6 gives me a -3. Is -3 less than -3? No, it's equal to. So this is not a solution. So you're seeing if the inequality works. Does it work or not? Okay? So on example 2, we're graphing these. So 2 says graph this inequality of y is greater than or equal to a -3/4 x minus 3. Okay? So we're going to graph this on a coordinate plane. X, y. Again, please make these as neat as possible. Now there's a couple ways you can do this. One of them is simply using the slope-intercept form, or the slope and then the y-intercept form and graphing it that way. Or if you want to, you can put the points in and solve like we used to. For me, I'm going to look at this and say that I'm going to use the slope and I'm going to use the y-intercept. Our y-intercept is -3. My slope is -3/4. So I'm going to go down 3 and over 4. I can also go up 3 and back 4. So this is going to be my line. Now, what we have to pay attention to with this lesson is, and we'll write it up here, So greater than or equal to or less than or equal to, that is going to be a solid line because it is equal to. If it's just the greater than or less than signs, then we're going to do a dotted line. This one is equal to, so it's going to be a solid line down through these. And then we are looking at this. If it's greater than, it's more than. So greater than, we will shade the top of this graph. Okay? So we're paying attention to equal to, whether it's a dotted line or not. And then is it greater than or less than? If it's greater than, it's going to be above the line. If it's less than, it's going to be below the line. Got a couple of those to do. So that was example 2A. To be, or not to be, we're going to do that one down here. So B says X is less than 4. So if we draw our coordinate plane, 4, and here it means that no matter what Y is, X is always going to be 4. So we can put dots anywhere. Now again, it's not equal to. It's just less than. So our line is going to be dotted. So it's going to look like this. And then it tells us it's less than 4. Less than 4 on another line means we shade in this section. Okay? So that is how we are doing lesson 97. Example 4 tells you to write an inequality according to the graph. Well, if you look at A, you'll notice that there's a solid line, and you'll also notice that it is colored in below the solid line, so it's going to be something is less than or equal to. And you'll also notice that it crosses the y-axis, and only the y-axis, there's no slope, and it crosses the y-axis at a -1. So you are writing the inequality according to that graph. If we look at example 4b, it crosses, if you count, on this particular graph, we're counting by 2's. Each line is counted by 2. So it crosses the y-axis at -4, so that's my y-intercept. The slope goes up, so therefore it's a positive slope. And if we look at the next place that it crosses what we call an intersection on our coordinate plane, it crosses at 2, 2. So if we go from -4, 0 to a x is 2, -2, changing y over changing x, so we have a -2 over -6. That's not right. -2 over, it's going to be positive. -2 over +2. So we're going to go up 2 over 2, or up 1 over 1. Okay, because it's positive slope. So they both have to be positive. So we go slope of 1x, y, and it's shaded above the line, so y is greater than, it's a dotted line, so therefore it's not equal to. So you're writing the inequalities, all right, on lesson 97. So there we go, lesson 97, graphing inequalities. As always, if you have questions, please message me, please text me, please call me and ask me questions. I can't help you if you don't ask questions. Here we go on the ones you don't do for lesson 97. 11, and then 13 through 15. you don't do. And then we skip over, you don't do 18 through 20. And then we cross out 23, 26 through 28, and 30. So those are the ones we don't do. Okay? Hopefully you guys have a good day and a great week, and we'll see you.